Hi, this is Erin Momedy, and I am in the thermodynamics class. I'm doing a project update on my research project for my final. I am doing a project that is a research paper on transatomic molten salt nuclear reactor, and I'm doing my video update to describe my topic. So basically, Transatomic is a newer company started by two MIT graduates, and they want to propose a new way to use a nuclear plant. And they have some of the main differences is the type of fuel that they use. They use waste burn, or sorry, they use uranium waste, and so they have a waste burning nuclear reactor. They also have a different reactor core fuel type. They use a molten salt as opposed to, and it's a very specific salt as opposed to a different type of salt. They also have a newer design for the moderator, which is going to help with their heat management and their schematic because of these new changes. Actually, I guess because of these new chemicals that they use, the different chemicals they allow for a different design in their schematic so that they can have a movable moderator, which means they can kind of control their heat better and their neutron utilization is better. Still learning a lot about this topic. I don't know a lot about it, but it is kind of lining up with what we're learning right now about power systems. So basically, what I narrowed down my project to was I was going to talk a little bit about what molten salt nuclear reactors are and a little bit about their history, but I wanted to focus in specifically on the transatomic schematics. They publish their white papers, which I don't understand at all, but it has a little bit of a background and has descriptions and kind of the chemistry and thermodynamics and engineering behind their new design. So I was trying to kind of figure out what it all meant and how to compare it. So how I narrowed it down for this project is that I was going to compare the two different types of salts. So it looks like the original salt used in the molten salt reactor that Ornell, the National Lab in Tennessee, used was a fluoride lithium beryllium salt, and Transatomic is proposing a lithium fluoride with an fluoride ion. I don't actually know how to say it, but it's lithium fluoride actinide fluoride 4. So I'm gonna look up what these are actually called, but they're different types of salt. The one Transatomic is using doesn't have any beryllium in it, which is interesting because if I remember right, beryllium is volatile, and one of the main reasons why they didn't want to use the original molten salt reactor. And then I was also going to focus in on the moderator differences. So Transatomic uses a zirconium hydride moderator, and the original Ornell designs used a graphite moderator. So I feel like there's some equations that I could extrapolate from that if I could figure out why they wanted to use those moderators. I mean, it has to do with the ability to manage the heat. I think that's what the moderator's purpose is. And so something about the zirconium hydride, I think in their white papers they specifically say because of its chemical properties, it doesn't degrade, and it doesn't degrade in a way that makes it create more waste product. So I want to look into that a little bit more. Maybe if I can look up I don't know, how the chemical properties of the moderators impact the thermal efficiency. That would be interesting. I don't know how I'm going to do that yet. And then the third thing I wanted to look at and focus in on this project is comparing traditional nuclear vapor power plant schematics to the Ornell molten salt nuclear reactor schematics and the transatomic schematics. They publish their schematic, but there's not very much data to each phase, and so I wonder if I ask them if they could give me some sort of model to just kind of learn from, if that's possible. I don't really know, but At this point, I have a lot more questions than I have answers. I think there's just a lot of things that I don't know. I'm really interested in the subject, but I don't really know where to start. So right now, I read through their white papers and tried to Google anything. I didn't really know what those terms were. And I'm rereading through the chapter 8 about vapor power plants and trying to understand a little bit more about the nuclear plants. The Rankine cycle, I feel like it makes sense, but my challenge is to bridge the gap between the basics that we're learning in class and these complex scientific documents about transatomic. I think I can do it. I don't really know what that's going to look like yet, but I'm pretty sure that someone, either Angela or someone else, will be able to help me figure that out. So I have a rough outline of my project written up. And by written up, I just have the rough draft started. And then right now I'm just at the phase where I'm trying to kind of gather enough information so I can create an even more clear path. I have 3 topics to look at: salt comparison, moderator comparison, and schematic comparison, but I don't really know what those are going to look like. I feel like with the salt comparison, I could get a little bit too deep into the chemistry of it, and I want to try to focus on the thermodynamics of it. Moderator comparison, I think I can relate back to thermal efficiency of the entire schematics, and then with the schematics comparison, I think that definitely relates to thermodynamics and what we're learning now. How do I want to finish this project? Well, I'm going to meet with Angela, and I think that will help me kind of narrow down my paths. I also would like to use this project as an opportunity to reach out to Transatomic and see if I can get anyone there to sort of communicate with me about the science behind their nuclear reactor. And then, oh, if you want to see some equations, I'm already at 7 minutes. Okay, so let's see. All right. So here's my computer screen. I don't know if you can tell, but here's the, this is the molten salt reactor schematic that they've provided for Transatomic. It's interesting because above it they have got the light water reactor, and so it's a really basic schematic, but you can see kind of how it's like the Rankine cycle, and then their version is also Rankine cycle, but we've got a little bit more going on. We have a freeze plug for safety, and then what do we have? Two heat exchangers, which is interesting. I don't really know what that looks like. And then there's also this schematic, and this is from their white paper. I don't know if you can see that schematic very well, but I'd like to redraw it and see if I could actually label the parts and see what information I can fill in based off of their thermal efficiency numbers that they published, and I don't know, power numbers that they published. If I can get enough numbers to fill in from what's entering and what's exiting, I might be able to kind of estimate or figure out what's going on in between all these different sections, especially if I know what the chemistry is, what the moderator products are, might help. Here's my book. I don't know if you can see that, but I'm looking into these schematics here and kind of focusing in on this area, because I think that's where the differences in the transatomic nuclear reactor and the traditional ones are. And yeah, I think those are my main tools that I'm looking at right now. Some other interesting things that they've posted, like I'll show you on their website. There's things like this. So here's a description of the 2 different moderators. I think that's interesting. The 2 different salts that I was going to look up, the beryllium-based salt and then the lithium-based, well, I guess lithium fluoride, uranium fluoride salt. Looking up those 2. Power density is really interesting to me. I feel like that's going to help me understand the cycle a little bit. And then these commercial plant details comparison will be interesting. Net electricity capacity. So there's some numbers here that are given that might help me kind of pick apart the schematic and understand it a little bit better. Right now I'm gathering data. I think my biggest challenge is that there's just a lot I don't know about the data that I'm gathering, so it's hard for me to organize it in a way that's useful. But I think, I don't know, I have, what is it, 2 more weeks? 2 weeks to focus in on this project, and then the last week to do the editing. I hope in the next 2 weeks to have something completed. So this week is going to be organizing this data in a way that's actually useful. Next week we'll be starting to write the project and just draw up the schematics and the comparisons, whatever I have to draw, get that done. Maybe I'll find a program to do it, or maybe I'll just hand draw it. And then the 2 or 3 weeks from now, so November 27th, I'd like to use that time to, especially that I have like something written up, I can use that time to actually fine tune it and maybe ask Angela more questions about what I'm doing. And also maybe at that time I can reach out to Transatomic and see if they can help me. I just don't want to go over there with nothing. I don't want to ask them for help when I haven't read all their documentation and organized my own thoughts first. That last week, turn in a rough draft, project wrap up, I can start to really refine my project and then, do all the editing that I can do, and then turn it in during finals. So that's my plan for now. Yeah, I'm kind of excited about this project. It's a little intimidating, but I think that I can narrow it down into something that is digestible for this course content, like that's relatable to this course content. So yeah, that's it. Thanks.